All right, for a rhombus, if we want to find what properties are sufficient conditions to prove that a quadrilateral is a rhombus. Okay, so again, we're starting with a quadrilateral. Okay, so by itself, a quadrilateral proven to be a rhombus requires what? Any ideas? So what? First of all, what's the definition? A rhombus is a quadrilateral with what? 4 equal sides, right? So all sides are congruent. Okay, if you have all sides congruent, then you know that you're dealing with a rhombus. Okay, anything else? Okay, actually, these two properties right down here are going to be sufficient conditions to show that any quadrilateral that meets either of those conditions is going to be a rhombus. Okay, so if the diagonals are perpendicular bisectors of each other, then you know that that quadrilateral is a rhombus. Okay, and then finally, the last one too, if the diagonals do bisect the opposite angles, also enough to show or prove that your quadrilateral is a rhombus. Right, when you're looking at the properties necessary or the properties that are sufficient by themselves to prove that a parallelogram is a rhombus, okay, so again, here we're starting with a parallelogram. So all the properties of a parallelogram already kind of implied to be true. Which additional properties would you need in order to demonstrate it's a rhombus? Did you guys come across something that specified a parallelogram to a rhombus? Okay, what would you need to know about the diagonals of the parallelogram in order for it to be a rhombus? You already know, because it's a parallelogram, you already know the diagonals are going to be bisectors of each other. So what additional thing would designate it as a rhombus? Diagonals would have to be perpendicular, right? Now, they don't have to be perpendicular bisectors. The fact that they're bisectors is already embedded in the condition of it being a parallelogram to start with. Hey, this condition right here, diagonals are perpendicular, it would not tell you that, or it would not be a sufficient condition to show a quadrilateral is a rhombus. And the reason for that is if you took a quadrilateral and the diagonals were perpendicular to each other, but they didn't bisect each other, you'd have what's called a kite. Okay, so it wouldn't be a rhombus in this particular case. So this condition has to also have within it the fact that you're dealing with a parallelogram. And that's why up here, when we used it for a quadrilateral, we included that it had to be a perpendicular bisector for that to happen. So again, be very careful. You're likely to see a question that relates those two things. Okay? In addition, if you know you're dealing with a parallelogram, how many consecutive sides would you need to be equal in order to guarantee it's a rhombus? If you know that opposite sides are already equal because it's a parallelogram, yeah, if you just have 2 consecutive sides, being congruent, then that's enough to show that each of the pairs of opposite sides will also be congruent, which gives you 4 equal sides, which gives you your rhombus. Okay, and then the final condition that is sufficient to show that a parallelogram is a rhombus has to do with the opposite angles bisected by the diagonal. And in this case, instead of needing both pair of opposite angles being bisected, all you need is one because you already know it's a parallelogram. So if you just have one pair of opposite angles bisected by that diagonal, that's enough to show that your parallelogram is in fact a rhombus.